Welcome back, everyone. Last week we added the microcontroller and we wired it up as wired control. We used our inputs and sent out outputs, being able to control the motor, steering, and speed control through that microcontroller and hand-wired remote. We also introduced the digital potentiometer, the on and off relay, and the steering relays left and right. For me, the next logical step is to get rid of the wired controller and add wireless to the system. As you saw in the demonstration at the beginning, I used an IR remote. I'm only using that as a demonstration purpose because that's what came with that Arduino kit. The IR isn't going to be a useful technology in a lit, open field environment. This week, we're going to make a design decision based on my research on wireless technologies. Let's look at the different wireless technologies and the most important features that we're going to need to do a wireless remote in an outdoor environment.
I created this chart to analyze each technology, and unfortunately we are going to move to the ESP32 microcontroller, so that puts that Arduino the Arduino microcontroller out of date. We won't be using that anymore. So unfortunately, we're gonna have to buy new hardware and work from that. And the reason why we're moving on to the ESP32 is because the ESP32 doesn't have any connectivity without buying extra hardware. It doesn't have Wi-Fi. It doesn't have Bluetooth. We could add on IR and RF modules to it, and I think you can add Bluetooth module to it, but I decided that after doing research that the ESP32 will be a better fit for us. What I put together here is a table if it's built in the ESP32, and as you can see, they're all yes except for the RF modules. You would have to buy extra hardware for that. I don't think it's very expensive, but if we think about RF, radio frequency would probably work pretty well in this situation, but then you also have to add extra hardware and figuring out how to use that with the ESP32. The range, again, we're working in the outdoor environment on the boat. We have to think about, I don't plan on using the remote any further than being on the boat itself. I've seen people, launch their boat and then use a trolling motor to deploy itself and drive it back to the dock. I don't want to do anything like that. One is, I don't know how reliable the connection is going to be. If I lose connection, then my boat is floating in the lake. Let's go over this. Wi-Fi is medium. Has medium range. Bluetooth is shorter. RF is long, and then ESP-NOW is long as well. All four technologies would be able to support our use case, but there's better options compared to the others. Latency is basically when you press the button, how long it will take for the motor to respond. With Wi-Fi, we're looking at creating its own intranet/web page to have controls on it. You're pushing the button on your phone through an internet site, and then that has to get transmitted to the controller, and then the controller has to transmit that back to the motor controls. Bluetooth has medium latency. Again, you're using that connection through your phone or Bluetooth controller to activate it on that microcontroller to tell it what to do. And then we have RF, which is pretty low latency, and then ESP-NOW is low latency as well. Let's talk about connection setup. As I was talking about with Wi-Fi, you have to connect your phone to the Wi-Fi that's created by the ESP32 microcontroller, and then you have to create buttons and how you want to control through that website. Bluetooth, the ESP32 uses a low energy Bluetooth model. I think there's other ESP32 chips that can do the classic Bluetooth, but again, not 100% sure how the connection process with Bluetooth. With the RF version, you have to buy extra modules and then extra setup for the microcontroller, extra code, things like that. And then ESP-NOW is pretty simple. There are samples of code of how to connect and send information back and forth between the two ESP32 microcontrollers. Next, we have power usage. Wi-Fi uses higher power. You'll have less battery life on your remotes. will have battery connections, so there's no real issues there. But if you did want to run it off its own separate power supply or battery, it's good to analyze this. The reliability of the connection, as I'm sure most of you have experience with Wi-Fi, you'll get drop connections. Bluetooth, you can have some interference. RF, again, you're just sending a radio frequency. There might be some interference from other radio frequencies, but I think the modules usually run on 433 megahertz, so there's not a big issue there. And then ESP-NOW, again, the reliability is very stable. You're sending packets that can be broadcast between the two controllers, and the protocol just seems very, very good for this use case. And then lastly, we can talk about use case. Wi-Fi, like I said, is using your internet or apps, going to a website that's created by the microcontroller, and you can definitely run it that way if you want. Bluetooth, you have your phone control. Again, I think that might be more difficult to develop something on iPhone. Maybe in the future I'll get an Android and be able to create an application on that side, but I don't plan on that. RF is good for long range remote control. Again, I think it's something that we could consider, especially if we wanted to stay on that Arduino platform instead of moving to the ESP32. But again, you're buying extra hardware and learning how to interface with that hardware. And then ESP-NOW is almost real-time control.
There you have it. I think I covered the wireless technologies that would best fit this use case. I still think that, unfortunately, I'm going to go with the ESP32 microcontroller. Some good things about it is an upgrade to the processing speed. I don't know how much that would actually impact our project, but I think it's a good investment to use newer technology and to use ESP-NOW protocol versus 3 other protocols that I analyzed. After our analysis, I think we picked a good technology to use, ESP-NOW. What I'm going to do next is order some new hardware. I'm going to order one ESP32 for our main console unit, and then another ESP32 for our remote control. I'll also work on implementing our relay controls for our on and off, steering, and using our digipot to control the speed. I'll have to work on the programming side of how to implement ESP-NOW, creating our remote, and having that communicate with our main controller to control our boat. Thank you for tuning in. I have a little bit of a teaser. During my research, I did find someone who was working on a similar project that they abandoned. We'll talk about this next week, but here's what they developed. I'm going to pick up from here and reverse engineer his design and implement. I'm sure we're going to implement some of his design ideas into our design. Thanks again, and tune in to the next episode. Thanks.